Have you wanted to write a Python program to shuffle a deck of cards? Or perhaps to check what files and folders exist on your computer? Or maybe a Python program that does your math homework for you? Well, in this Python fundamentals tutorial, we're going to take a tour of a few built-in modules of the Python standard library. And these just may be what you need for your next Python project. So without further ado, let's get started. If you have already installed the Python interpreter on your computer so you can run Python code, then you would also have a collection of hundreds of Python modules installed on your machine, and this is known as the Python standard library. We can use those modules anytime we want in our Python programs without any installation because they are already included in the Python installation. And in this video, we will be exploring 3 of the most useful and powerful modules included in the Python standard library, and hopefully these will come in handy whenever you write any more Python programs. The first module we're going to look at today is the random module, which is one of the most powerful and most useful modules in the Python standard library. Because it's a built-in module that came with the Python installation, we don't have to do any extra installation to import it. So we can just directly write in Python import, then the module name, which is random. Running this cell, you can see the cell is run. Now we have access to all the members of the random module. Perhaps the most used function in the random module is the random.randint function. Randint stands for random integer. If I pass in a and b as arguments into the randint function, it would return to us a random integer between a and b, including both endpoints. So if I run this cell, you can see random.randint with arguments 1 and 9. This is going to return to us either 1, 2, 3, 4, 5, 6, 7, 8, or 9. And it's going to select a random integer among those numbers. And because this is in a for loop of range 20, we can see 20 random integers between 1 and 9 printed out. And this line is just to demonstrate how we can also pass in negative integers into the function call. So -9 to 9. And you can see negative numbers also work with the random.randint function. Another function that is quite useful in the random module is the random.choice function. Let's say you have a sequence, so a list, a tuple, a string, etc., and you want to select a random element from that sequence. Well, you can pass that data into the random.choice function, and the function call will return a random element from that sequence. Here, I have a list of different programming languages, and say I want to choose one of those programming languages to learn next. Well, I can just pass that list into the random.choice function, and this whole thing will be a random element from this list. So it can be SQL, it can be R, it can be JavaScript, and also those 4 as well. And in this for loop, let's run this, and you'll see Swift, C, SQL, and Python as the output. And the random.choice function also works with strings. So here we have a string Python, and random.choice, a string, is going to return a random character in this string. The last function we're going to look at in the random module is the random.shuffle function, which shuffles a list in place. Note that the original list that's passed into the function call is modified, and there is no new list created nor returned. Here I have a list of letters in alphabetical order. After printing it out, I call random.shuffle with the argument another list. Let's take a look at what the output is going to be. We can see, firstly, we get A, B, C, D, E, F as the output. And after we call random.shuffle another list, we can see another list is now in a completely different order. Notice that I don't write, say, another list is equal to random.shuffle, since this function call does not return anything. It's actually going to give us the result none. That's going to be what's stored in another list. Since we don't want to see none, we don't write anything before random.shuffle. Running this, you can see it's in a different order now. With all the modules in the Python standard library, there are many members in those modules, and it would be pretty difficult for me to talk about all of those functions. And in the description of this video, you'll find links to official Python documentations of the modules that we're going to talk about today, including the random module. Math is one of those things that computers can do really well, and much faster than humans can. And for that reason, Python has a built-in module in the Python standard library just for math, and it's called math. So you can see in this cell, I've imported the math module. Running this, we can now access the members of this module. Just like how we can store functions inside modules, we can also put variables inside our modules. And in the math module, there are a few variables that represent math constants, like pi, e, and tau. There's also the inf and nan. Inf stands for infinity, which usually we use to represent an arbitrarily huge number, and nan stands for not a number, so it's not actually a legal number, and there are certain places where you can use that. So let's run the cell and you can see the math constants printed out. In the math module, there is math.degrees and math.radians functions. These allow us to convert angle values from radians to degrees, so that's the degrees function, and the radians function converts an angle from degrees to radians. If I want to see what 180 degrees is in radians, I can pass that into the radians function, and we'll see that 180 degrees is around, or it's exactly pi radians. 321 degrees in radians is going to be, well, less than 2 pi. And if I want to see what 2 pi is in degrees, then we would see it's 360 degrees because we passed in 2 pi into the degrees function of the math module. Notice how I used the math constant math.pi here instead of just handwriting 3.14, since that will actually give us a slightly inaccurate number, which we don't want. So you should always use math.pi if you would like to use the math constant pi. Same thing with 5 pi over 4, it's around 225 degrees. The math module in Python also has the math.sine, math.cosine, and math.tan function, and these are used for trigonometry. Note that we can only pass in angle values in radians into the function calls as the parameters. We can't pass in degree values directly. We have to convert it into radians first. In here, we can see pi over 2 passed into sine, that should be 1. Negative 12 pi, the cosine of negative 12 pi should be 1 as well. And 30 degrees, we convert it into radians first, and then pass into the tan function. Tangent of 30 degrees should be root 3 over 3, I believe. And we get the answers just as we expected them. For trigonometry, Python's math module also has functions for arcsine, arccosine, arctangent, inverse hyperbolic sine, cosine, and tangent. But I'm not going to go over those in this video since these are more specific to certain usages. Perhaps not the most used among the math module functions, the math module also has the math.comb and math.perm functions for combinations and permutations. Math.comb AB is going to return the number of ways to pick A or B unordered items from A items without order and without repetition. Same thing for the perm function, just with order is going to be the difference. So we can see if I want to pick 2 items from 3 without order and without repetition, it's going to be 3 ways, and with order is going to be 6 different ways. There are many other functions in the math module as well, so I'll leave a link down in the description so you can learn more about those functions. The third and last Python standard library module we're going to look at in this video is the OS module. OS stands for operating system, and this module allows us to manage our file system. So we can create and delete and rename files and directories. Directory is just another name for folders. So importing the OS module, we can just write import OS and we can run this. One of the most used functions in the OS module is the os.listdir function, and this stands for list directory. Now we can pass in a string into this function, or we can choose not to. If we choose to pass in a string into this function call, then it would return to us all the directories and files in the specified folder which we pass in. By default, if we don't pass in anything, it's going to be the current working directory. To demonstrate that, I have called os.listdir, which returns a list, and I have printed out that list, which we can see is right here. Just for reference, I have also found a directory tree of the current working directory on my computer. We have 3 IPython notebook files, we have 2 Python files, and a notebook checkpoint folder with a file in it. And we also have a test folder that I made with a txt file and another folder inside. And we can see those are accurately reflected in the output right here. Although we don't actually see this checkpoint notebook file in the output because that is not inside the current working directory. It's in another folder that's inside the current working directory. And if I want to see what files and folders are inside a folder called test folder, which we can see exists here, I can pass that into os.listdir, and we can see another folder and text.txt as the output. Now, there are also many more functions in this module, things like making directories. We can also delete files. We can also do a lot of different things like handling file paths and such. And just like before, I'm going to leave a link down in the description where you can learn more about this powerful module. To wrap up today's video, today we talked about some of the most used members built into the Python standard library, but what we talked about is by no means a complete list. In fact, here I have open an official Python documentation website of the Python standard library, and you can see just how enormous this list of modules is. We have modules like datetime, which we can use to interact with dates and times. We have things like calendar to interact with calendars. And we also have different things like, for example, CSV module, which we can use to interact with comma-separated value files. I want you to take away from this video just how many possibilities the Python standard library has opened for Python programmers. So let's get started importing. And that's it for a brief tour of the Python standard library. I hope you enjoyed this video. Don't forget to like, share, comment, and subscribe to Future Programmer to learn more about programming. With that said, thank you very much for watching, and I will see you in my next video.